Here's a challenge. Before we get started, I want you to take a moment to think about how many things you believe is connected to your home network right now. Over the next few seconds, I'm going to introduce my channel, Bit Shifter. This will give you a moment to put together a guess. By the time we get to the end, you'll know for sure how many things you have connected to your home network right now. So start thinking about it. My Bit Shifter channel is committed to educating everyone about technology. In this episode, I will explain some important things related to your home network. If you pay close attention, you'll see some very specific techie terms that I feel are important for at least one person per household to know and understand. All of this information is a stepping stone to a more private and secure internet experience. Adding the information in this video to your personal technical knowledge will help you understand everything else related to internet connected devices. So like and subscribe, not for me, but for you, so you can easily come back to the Bit Shifter channel and reference this later. Share this video with people who need to learn this information, because they do. Okay, you've had time to think about how many devices are connected to your home network, so write that number down. And by the time we get to the end of this video, we'll see if you're close or if you're far away. So things have changed a lot over the last 25 years. Once upon a time, there was a computer that dialed into the internet. The audible sounds of that ding dong was an obvious sign that you were getting ready to embark on a journey that would provide a slow feed of text and pictures to satisfy your curiosity. Taking information in slowly, just a single browser window. There were no tabs back then. It gave you time to think and process what your next move might be, even how stupid your search query might have been. I think we read a lot more back in those days. Web search engines were slow to come onto the scene, but eventually we got good results. And this was important to get the best out of your 20 hours a month of dial-up networking. As the internet popped in popularity, more options were created to provide families a full-time internet connection. And with this came wireless internet, or Wi-Fi. You know what's strange about the term Wi-Fi is it has nothing to do with high fidelity, wide fidelity, or anything related to fidelity. It's not an acronym at all. It is a marketing and standards organization that probably had no idea that they would be as big as they are today, establishing the technology that everyone depends upon. You can see them at y-fi.org if you want to look it up. I'll have a link below. Since people had always on internet at home, computers could always be on and ready when you wanted to engage in anything that required internet access. Maybe not so convenient with a desktop computer, but for those new foldable laptops, this was looking good. And with Wi-Fi so prevalent, manufacturers started integrating Wi-Fi hardware into, well, everything. Laptops and tablets and of course smartphones. We used to have add-on cards for Wi-Fi, but we didn't need those in our laptops anymore. It became a standard. In our area, if you lived within the city limits of our small towns, you could use your telephone lines to carry a DSL, or digital subscriber line, that was always connected. And if you had cable for TV, you could use that to provide even higher speed internet. We had those with it. And then we had techie people like me that lived outside of those boundaries without it. And it was terrible. But we got it eventually. Not only did we get DSL from an oversubscribed Frontier provider, but we ended up with a better solution in point-to-point wireless. Yeah, point-to-point wireless from miles away that was decent. And now I'm running fiber out here in my rural area, which is blazingly quick. Before we get into the details of what a modern 2024 internet connected home looks like, let's simplify this. Let's go back 22 years when always on internet services just hit the scene. This will make it easier. In 2002, you might have had a video game console that could connect to the internet. Sega had the Dreamcast, so you would need some sort of, I think, an adapter. I can't even remember if that was Ethernet. Sony had a PlayStation 2 that would have required an adapter. And Microsoft's original Xbox could plug directly into Ethernet. So in your house, besides a laptop, which you could use Wi-Fi, or you could connect it directly to Ethernet, a desktop computer, the more traditional thing, well, that would connect directly into your router with an Ethernet cable. But you might have had an Xbox, and if you did, another Ethernet cable. And of course, later on, we had other consoles that just did Wi-Fi, and you also could have connected them via an Ethernet cable. And then that just grew on until everything has wireless connections. But the point is to keep this simple with just a few devices. So hang on. Assume we have an Xbox, the original, and it's wired. Assume that we have a desktop computer and it's wired, and that we have a laptop computer and it is using Wi-Fi. So we're going to get a little more technical. So put on the technical hat. I've got my technical hat on right now. My American Museum of Science and Energy hat from Oak Ridge, Tennessee. Go check that out. Very cool place. But we're going to get it on and we're going to talk about the technical bits and pieces. Your home would have been given an IP address. This is an important part of the conversation because this IP address is like a house address for your mail and packages. That IP address is placed inside your router. And your router, as simple as I can make it, has three main jobs. Now, I said this is going to be simple, but there's a lot to take in on these three main jobs. And in fact, I might make it 4. I think I'll stick with 3. What are those 3 jobs of your home internet router? Number 1, handle your internet connection with your provider. This means it will send and receive internet data through your IP address. Think of your router as a pizza that's been cut into slices, and one slice is going to deal with your internet provider, and that's it, nothing else. It will have an IP address. What is that? IP address means Internet Protocol, and that's going to establish a common set of rules for how information is going to be sent and received to your home. This IP address is an identity. It is your address to your house. But remember, you got 3 devices in your house, so you have this address that your internet service provider has given you, but it doesn't have specific IP addresses for the devices in your house. In the simplest way of thinking about this, there are 2 types of IP addresses that we're going to discuss. There's the one I just mentioned that's dealing with your internet service provider, or ISP. And then there's a whole set of other IP addresses that's going to be set up to talk to your devices in your home. So hang in there. We're going to discuss that real soon. Like right now, DHCP is the number 2 thing that your router is going to handle. DHCP is Dynamic Host Configuration Protocol, and almost no one uses that long explanation when we talk about it. We just call it DHCP, and that's alphabet soup for a method in which your internet receptionist, so I'm going to keep relating to an internet receptionist, is going to keep track of who is on your home network. So think of the idea here of a receptionist. If you were to go on the 14th floor of some building in a big city and you wanted to talk to ABC Gaming Company, and you walked up to a desk with their pretty logo, you would speak to a receptionist, and that person could then direct you to specific people inside that company. DHCP entails a very personal piece of information that you know about, and that is the MAC address. A MAC address is like a social security number for your device. It is a number in binary that is representing hexadecimal. Holy cow, what does that mean? It's crazy. All this means is that we have ones and zeros that make up all kinds of numbers, and a MAC address is made up of ones and zeros. So we can't really read ones and zeros easily. It just drives our brains crazy. So instead we convert that to something called hexadecimal, and that's base 16. Hexadecimal uses numbers 0 through 9, and then when we hit 10, we use letters A through F to reach 15. It sounds crazy, but my students, trust me, they all get it, and they get it within just a couple of days whenever I teach it. We just call it hex. And again, it's used to help us represent binary numbers, but without all those crazy numbers that get so long. So there's nothing new with this hex numbering system. We're connecting it to the fact that your MAC address has a hex number, and it's rather long. This hex number is broken into two parts for your MAC address. The first half represents the company that makes your network circuitry, and so we're going to call this the vendor ID. The last half is a unique number that is one of one in the world, and so it identifies your specific device. What devices are we talking about? The circuitry that makes up your Wi-Fi capability and everything, or the circuitry that is associated with your Ethernet port, which will take a Cat 5 or 6 cable whenever you plug it into that device. Think of a laptop. If you didn't want to use wireless and you plugged in with an Ethernet cable, then you would have a MAC address of that Ethernet cable. But if you decided to go wireless, you would have a different MAC address associated with the vendor who made that specific wireless access device inside your laptop. And so you would have a unique number for each, right? These together with the vendor ID and the unique number are the MAC address. There are no two MAC addresses alike. I say this as theoretical because it is possible to copy a MAC address. You can create one that has been made already. And there are accidents that happen, like whenever we had a 1,000 PC Dell desktop order at a place that I worked at and found that a couple of machines had the same MAC address, which should not happen, but it did. So it was an accident from the factory. But for our discussion, the MAC address is like a social security number. It's unique to the device that is connecting to the internet in your home. If you connect using an Ethernet cable, you have a MAC address. If you connect using Wi-Fi, well, you'll have a different MAC address that is associated with that. Hopefully that all makes sense. So this MAC address is presented to your router whenever you connect to your router. It sees that you want to establish a connection with your home network. If you are wireless, you hopefully have a password set up to connect. I do hope you do. If you are plugged into an Ethernet port, you usually have to set to just accept that connection as a trusted, friendly device on your home network. Pretty simple, and honestly, probably not very good. People slip into your home and jack into your house. Do they have access to your network? Yeah, they probably do. Maybe you shouldn't have strangers in your house. Once the router sees its MAC address, though, it will write it down in its table of connected devices and then hand over a very private IP address. Hold on a minute. Man, I just talked about IP addresses. I talked about that your router has an IP address coming from its internet service provider. But now I'm talking about a private IP address. Yes, I am. This private IP address, well, not just one, but many are going to be handed out to every device in your house. So why? Why is that? It does this because IP addresses are how we're going to get messages back and forth on the internet. We don't talk in MAC addresses. Well, we kind of do, but that's at what we would call a lower layer on the OSI model. The communications that we're going to talk with Internet Protocol is IP. That's why we call it IP. We just use this to get approval, this MAC address, for our IP address. And another way then to look at this is consider that the MAC address is like an employee ID badge that was created for an employee whenever they got hired. And then it says, hey, I'm authorized to be here. And in response, that employee gets an office and a mailbox associated to that office. And that mailbox then is the private IP address. Now the receptionist who is receiving these messages from the internet can direct that message to the rightful person through their private IP address. Right? Messages come into a receptionist. Think of them as boxes. The boxes are cut open, and inside of the box is individual packages, smaller ones, for employees. And the receptionist can route that package now, these smaller ones, through a business to individual employees because they all have their own private IP address. There's no direct communication from the internet to the individual employees, or in our case, the internet to the individual devices in your home, unless they go through the router. And something has to keep track of all these MAC addresses and hand over these private IP addresses. And that's the job of DHCP. There's more you can do with DHCP. For example, you can always make sure that a printer has a specific IP address based upon the router seeing your MAC address for this printer. We call that static IP addressing. We would use a reservation. I just thought of that. Yeah, we would create a MAC reserved IP address. So that means based upon the MAC address, we reserve a specific IP address. That's very helpful whenever it comes to connecting up a printer. That's where I usually use that, is whenever I have a printer in a small business or on a specific floor and we want to access it. So we will reserve an IP address for that specific printer, and we can just let DHCP do its job with everybody else dynamically. What does that mean? Well, this case dynamic is where an IP address is handed over to you for a while. And if you have a friend come over, for example, with their laptop or their phones and they connect to your Wi-Fi, they will be given a dynamic IP address. DHCP hands one over. And if they come over a month later, it is possible that the IP address handed to them will be different. These expire. There's a lease, and then they expire. This is done to ensure that you don't waste IP addresses on devices that are no longer needing them. In 2002, you would hardly need to care about this in your home, but things changed rather quickly a decade later or more. So that's the second thing, DHCP. The first thing was handling an IP address coming from your internet service provider and that internet activity. But then part two was creating IP addresses that are private in your home and are connected to MAC addresses. So what's the third thing? Handling NATs. Number 3 is handle NAT. NAT is network address translation. So going back to our receptionist idea, the receptionist, which is your router, has a list of everyone that is supposed to be in the office complex, which is your devices, and that is in the form of MAC addresses. Now they all have assigned mailboxes and offices, and so those are authorized in the form of private IP addresses. So the receptionist then will direct a very large volume of messages. Your router has an IP address for the outside world, the internet, and when they receive a message from the internet, this receptionist, they look at it and see who it's for, and they're going to direct that traffic toward that private IP address. When you are ready to send something like a YouTube search to the internet, the receptionist will handle the information request, repackaging it in a way that makes it ready to send out to the internet and then let it go. Going in the other direction, let's say that you have your YouTube request results coming back to you. NAT, or the receptionist, will get this package of information, open up the box, and inside they see that the information is specifically for your laptop. Then they direct that information to you using your private IP address. That's basically how NAT works. When information from the internet gets to your house, the receptionist opens up the package to see who it's for and then directs the information to that person. Again, going the other way, they take your information, package it up with a big stamp of the router's IP address, and then they send it to YouTube or wherever you're wanting it to ship off to. It's really cool, isn't it? It's like those Russian dolls that have a doll inside of it and another doll inside of it. All the way inside, the smallest doll has the exact information, but every bigger doll is just some sort of package that has a destination that it's trying to send it to. Okay, so let's rewind and look at our example. It's 2002. You have 3 devices: a desktop, a laptop, and the original Xbox. The desktop PC was connected with an Ethernet cable. The laptop's using Wi-Fi, and that old original Xbox is using an Ethernet cable, just like your desktop PC. Each connection has an IP address that the router has provided. That's a private IP address. The router provided these IP addresses because each device handed over its MAC address. Remember? That's how they got connected to the router to begin with. And the router, using DHCP, put these MAC addresses in a list so that it knows exactly who is making requests and receiving responses from the internet, therefore being able to direct that information to the correct device. The Russian dolls. Is knowing about IP and DHCP, MAC addresses and NAT, and all this, are these all important? I think they are. I think they're not just important for a techie user, somebody that's trying to get an IT job, but I really think it's important for the normie user who wants to step up their knowledge. There needs to be somebody that you know that is really slick with this stuff, and why can't it just be you? If we look at 2024, the number of things that you might have connected to the internet in your home is staggering. Now, I'm a very technical person, but I'm a cautious person about what I connect in my home. That means I have a lot of things connected, but fewer than some might think. There are several devices that I've removed or I will never connect due to privacy concerns. And so I'll have future videos that will hit up on that topic down the road. So I have all kinds of things connected in my house. And to help you see what you have connected in your house, you can repeat a simple procedure that I'm going to do right now. I'm going to open up a command prompt. And the way that we open up command prompts is we hit the start button and type command. COMMAND. And in this command prompt, I can type ARP space -A. ARP is Address Resolution Protocol. And it's a whole lot less important to know what ARP stands for and more important to know what it is. This is a database that is built over time by my Windows computer, this desktop that I'm using. And it's going to help this computer communicate with other devices on my network in the most efficient way that it can. So whenever you type ARP-A, you get the current list of devices that Windows is aware of. After a few minutes, Windows is going to check again to see if this device, any device on that list, is still out there. If it's not, it will remove it. So this glance at who is connected to your network isn't always going to show you everything that's on your network, but it's a way to take a quick peek. So if you look at my list, you will see that I have all of these IP addresses that start with 192.168. Those are private IP addresses. And that has been established a long, long time ago that 192.168 is private. This number is not allowed to be pushed out on the internet, but it is very much what we want to use in a small office or home. So if you count the number of IP addresses that I have that start with 192.168, I think we will have somewhere around 14 or 15. We won't count 255. We don't. Don't worry about it. Saving time. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like we have 12 IP addresses that start with 192.168. We're ignoring .255 at the bottom. And then we have these physical addresses, these unique MAC addresses. And note that it says that these are dynamic. So these are dynamic IP addresses using DHCP. That's what that is. And then you see some of these that say 224 and 239, and these say static. And so that has to do with something different that is beyond the scope of what we're talking about today. So we'll keep that number of what, 12? But that, you might think, wow, I did good. I guessed my number right. But that's not enough, because all that does is give you a glance at what your Windows computer can see. And in a future video, I'm going to break down more about these numbers that are used for IP and Mac, and you'll see more details. But for now, you can take away that you can use this tool to see at a brief moment what your Windows computer is seeing. Mac people, I'm sure there's a way to do it. I just don't use Macs. Now there's a better tool, and it's way better, and it's a free one too, and everybody likes free. And so that tool is called the Advanced IP Scanner. So if you do a search for Advanced IP Scanner, I'm using DuckDuckGo. The first thing that pops up is Advanced IP Scanner, download free network scanner. So I'm going to click the green button and download a copy. And it's actually happening right now. I'll save it, and then I will run it. Your options are to install it or run it as portable. I'm going to be keeping it on this desktop computer. So I'm going to run it as normal. I accept the agreement and it installs. I click yes that I want it to install, and now I'm going to run it. So the Advanced IP Scanner is ready to go, and all you have to do to keep it so simple is click the scan button. Now it is going out and sniffing like a hound dog to see what is all out on your network. And it's kind of neat to watch as it's populating. By the way, there's other scanners out there, but I like this one because it gives you a very clear and concise report of what it sees on your network. Now I had 12 devices that Windows could see. But what does Advanced IP Scanner see? So far, the number is 18 alive, it says. Now 21, now 23, now 27. Holy mackerel. 27 alive, maybe even some more. We've got a few seconds to go. So I've ran Advanced IP Scanner to completion. I have 27 devices that it found. If you look at the left column, it's going to resolve a name for that device if it can find one. Otherwise, it's just an IP address. So if you look at my list of IP addresses here, 150, and then it takes off with 109 and keeps moving downward. Now I configured my router specifically so that DHCP will hand out dynamic IP addresses. Those are the ones that change as time goes by if they don't stay connected to the network at your house. Mine start at 100. So I've got 109, 114, and so on until we get to 248. Dot 1 is related to a router, and dot 50 is related to another router. And then, like I said, I move on with the normal assignments. Now yours might start at dot 1 and just have all kinds of different devices from there to 254, and that would be normal. Now, that's the middle column that says IP. Back to the name. So some of these devices that have a name, that means that that name is being broadcast across your network. So it's not just an IP address, but it might be a name that means something. So for example, Sorcerer and Black Rose are both computer names that I have. And I use those to keep track of which specific devices, if I see them on my network. That's not normal. Most people don't care, but that's what I do. Also, Libra Elect RPi 400 is a Raspberry Pi 400 device that I have out in my shop, which is about 500 feet away, and it is wired through an Ethernet connection. But it is there so that I can use it as a media center out of my shop. And you can see over here in the third column now, under manufacturer, this manufacturer is saying Raspberry Pi Trading Limited. That is what has come up here. And how did it come up with this manufacturer? It came up with it through DCA632. That's the first half of the MAC address for this device, and this device is a Raspberry Pi. So that is expressing more information, way more information than ARP-A did or could. So all these manufacturers that you can see, some that you don't see because it couldn't resolve those, but all the rest it could, are related to these MAC addresses, at least the first halves of them, as those are the vendor ID, just like I talked about earlier. So if you have a Dell laptop, it is very possible that the manufacturer of the Wi-Fi device that's installed in that laptop isn't Dell. If I did a test on my Lenovo laptop, which I did earlier, and I was using Advanced IP Scanner, my MAC address was coming up with a manufacturer of Cloud Network Technology Singapore. Now you know why the brand name of your computer may not be showing up here in this list. So if you don't see anything related to the brand name of a computer that you're using, it's normal. It just means that a different manufacturer made that particular network device. So if it's Wi-Fi, that little Wi-Fi device inside, probably not made by Dell. It might be made by somebody else. So then, what is the purpose of me directing you to all of this information, and what can you do with it? Well, the title of this video is Exploring Your Home Network, Uncovering the Unseen. So, did you have any clue that you had this many things connected to your home network? And are there any surprises? Now, in my case, I know what most of these are, but there are a couple, there's more than a couple, that I am not exactly sure. And I do have a fairly well-connected home with all kinds of devices. But let me give you a hint. Some of these devices that you may see here could be related to all kinds of smart devices in your home that you forgot about. Remember at the beginning of this video, I challenged you to guess at how many devices were connected to your home network. How did you do? Share with all the BitShifter community in the comments below if you were surprised with the results, or if you weren't. The point of this video was to bring you to a deeper technical understanding of what is going on in your home. From here, I can take you further into a discussion about cool technology that has a network connection, and you'll understand the terminology. But more importantly is to start thinking about why you want to minimize this list, especially when the devices on this list aren't in use. Gone are the days when you had a desktop, a laptop, and an Xbox as your only home network stuff. In 2024, if you have a moderately large house with teenage kids, you likely have multiple smart TVs, smartphones everywhere, Amazon devices like Alexa and Ring doorbells. You probably have security cameras, Google devices, possibly some appliances, a thermostat, lighting control systems, and then the traditional stuff that we started with like laptops, desktops, and game consoles. Why are all these devices always on your network? My list shows 27 devices, and I'm the only one in the house. Should all of these be on? Are they vulnerable to an attack? Do they need firmware updates in order to secure them so people aren't using your cameras to spy on you and the property that you have your cameras pointed at? Lots of those questions will be answered in future videos that I will do on this channel. Let's recap what I've covered. 9 important things. Number 1, you have an internet connection to your home from a provider, and we call that an ISP, Internet Service Provider. You have a wireless router. Either you bought it or it was provided to you by your ISP. Number 3, your ISP has assigned an IP address to your home router so it can communicate to the internet, and the internet can communicate with your home. Number 4, you have wired and wireless things connected throughout your house. Each one of them has a MAC address, also called a physical address. That is like a social security number for each device. This MAC address has information in the first half of it that will identify the manufacturer of the network device, and the second half of it is unique. It should be unique, and there should not be another one like it anywhere in the world. Number 5, each device that you connect, whether wirelessly or wired with an Ethernet cable, will get an IP address. This is a private IP address. And a DHCP server that is built into your router will hand out these IP addresses to each device. Number 6, your router has a table of all devices connected to it. That puts a MAC address to an IP address, creates a relationship between those two. Number 7, your router uses NAT, which means Network Address Translation. And this acts as a receptionist. The receptionist opens up the packages that it receives from the internet service provider and delivers the information inside to specific devices in your home. The receptionist also boxes up messages from all the devices in your home and then ships those out to the internet through your ISP. That way it can send messages to various websites, video streaming sites, social media sites, and on and on and on. Number 8, we can take a peek at all that is connected in your home with a simple tool. ARP-A at a command prompt, or to see everything, Advanced IP Scanner. Very simple. Download it, install it, hit the play button, and have a look. Lastly, I hope you're processing this and coming up with a few questions. Just because a device can be connected to your home internet, should it be? Does a smart TV or video game console that isn't powered on still need to communicate with the internet? What are they doing right now showing up on your list when they're not even in use? Does this pose a threat? Are you vulnerable to some sort of attack? Have you checked to see if the firmware is updated to the latest stuff anytime, ever? Probably not. These are all good questions that deserve an answer.